In this experiment, you're going to determine the concentration of an unknown solution of barium hydroxide. You're going to titrate the barium hydroxide with a standardized solution of sulfuric acid. You're going to monitor the titration with a conductivity probe. The conductivity will start out initially high due to the presence of barium ions and hydroxide ions in solution. As you add sulfuric acid, the hydrogen ions and hydroxide ions will react with each other to form water. The barium ion and the sulfate ion will combine to form slightly soluble barium sulfate. The conductivity of the mixture will decrease. At the point where you have the same number of moles of barium hydroxide and sulfuric acid, the conductivity will reach a minimum value. After that point, the conductivity will increase due to the ions from the excess sulfuric acid. You will use the volume that gives you the minimum conductivity to determine the concentration of the barium hydroxide solution. We're going to calibrate a CBL conductivity probe. To start out, press apps on your calculator, select ChemBio, press enter, go to Setup Probes, number probes 1, type of probe, select conductivity. We're going to set the switch on the conductivity probe to 0 to 2000. It's in channel 1. We're going to perform a new calibration. We're going to wait 30 seconds for it to warm up. Press enter. This is a 2-point calibration. The first point, I'm going to remove the conductivity probe from the distilled water. The first point will be in air. We wait for the reading on the CBL to be stable. We press trigger on the CBL and enter a reference value of 0. We'll place the conductivity probe in the standard solution, wait till the CBL reading is stable again, press trigger on the CBL, and enter a reference value of 1000. We will get a slope and intercept for the calibration line, and this will take us back to the main menu. We've standardized our conductivity probe. We're now going to prepare our sample. We're going to pipette 50 milliliters of an unknown solution of barium hydroxide into the 250 milliliter beaker. We're going to add 120 milliliters of distilled water to the beaker. We're going to stir the mixture. We'll take our conductivity probe out of the distilled water, put it in our solution, and clamp it in position. We want to make sure that our magnetic stir bar does not hit the probe. We're ready to collect data. Arrow down to collect data. We're going to use trigger prompt, arrow down to trigger prompt, press enter. Wait for 10 seconds to warm up. Our first data point will be when we've added no sulfuric acid. So it'll be 0 milliliters of sulfuric acid added. Our initial data point will be 0 milliliters of sulfuric acid. When the CBL reading is stable, we'll press trigger on the CBL and enter a value of 0.00 on the calculator. We're going to ask for more data. Add 1 milliliter of the sulfuric acid solution. When the CBL reading is stable, press trigger and enter the volume of the burette reading, 1.00 milliliters. You will continue to add the sulfuric acid in 1 milliliter increments. Wait till the CBL reading is stable each time, press trigger, and enter the volume off the burette. Continue to do this until you've added about 30 milliliters of the sulfuric acid solution. As the sulfuric acid reacts with the barium hydroxide, very slightly soluble barium sulfate is formed. We see this as a white precipitate in the beaker. The conductivity of the solution decreases until you reach the point where you have the same number of moles of sulfuric acid as barium hydroxide. The conductivity will then increase due to the excess sulfuric acid. You will use the intersect program to find the point of minimal conductivity. At that point, the moles of barium hydroxide equals the moles of sulfuric acid. You know the concentration of the sulfuric acid. You will solve for the concentration of the barium hydroxide.